Welcome to Lesson 5.6, Implementing Access Control Models. In your Candidate Information Bulletin, we are in the Identity and Access Management domain, and we are in Key Area of Knowledge E, which is Implement and Manage Authorization Mechanisms. Our topic for this lesson will include access control models and techniques, mandatory access control, discretionary access control, and role-based access control. So an access control model is a framework that dictates how subjects access objects or how objects access objects. So either how an active entity accesses a passive entity or the information flow between two passive entities. Access control models are built into the operating system in some applications. So the access control model you choose has to already be a standard part of the operating system or the application that you're using. So we have a number of access control options, various models and techniques, and these include mandatory access control, which we'll refer to as MAC, discretionary access control, which we'll refer to as DAC, role-based access control, which we'll refer to as RBAC, rule-based access control, content-based access control, context-based access control, and constrained interfaces. In this lesson, we're going to focus on MAC, DAC, and RBAC. In the next lesson, we will be looking at rule-based, context-based, content-based, and constrained interfaces. So in a mandatory access control model, or MAC, implementations compare a subject's clearance and their need to know with the object's classification to determine the level of access and granular permissions. So in a mandatory control model, every subject and every object must have a security label because we're going to be comparing those labels. Mandatory access control is rarely used in a commercial environment. It is primarily used in secure military and government systems. So let's look at object security labels. Object security labels, which are classification and category, are assigned by an authorized system officer. Now, we discussed this earlier. This has to be someone who has been trained and has been credentialed in applying security labels. Object classification labels are based on sensitivity, and object category labels are based on need to know. So we're both labeling the classification of the information as well as categorizing the information based on who may need to know that information. Clearance is what we apply to a subject. So a subject's clearance has to be equal to or greater than the object security level. So let's do that again. The subject's clearance must be equal to or greater than the object security label. Subjects are assigned clearance through a defined provisioning process, which includes a thorough background check and a formal vetting process. Then subjects are further assigned their need-to-know categories. So our objects are given their classification by an authorized officer. The subjects go through a complete HR vetting process, a background check. It's actually a process that can take months into years. So then they're assigned a clearance level, and then they are further assigned their need-to-know categories. So let's put this together. Let's look at just a simple MAC matrix. We're not looking at categories or need-to-know defined here. But just going back to our classifications of top secret, secret, and confidential, those are the categories across the top, and then going down the left-hand column are our subject clearance. Our subjects could be given top secret, secret, or confidential. So they have to, again, be equal to or greater than. So if I have top secret clearance, well, I can get to top secret classification data. I can also get to secret and to confidential because my security label is equal to or greater than. You'll notice if I have secret, though, I cannot get to top secret information. I can get to secret, and I can get to confidential. And if I have confidential, I can only get to confidential. Now, again, this is a very simple matrix. We're not taking into account here categories or need-to-know definitions. MAC object guards are software and hardware guards that enforce the secure exchange of data between objects of different classifications. A software guard manages interconnectivity by filtering and processing requests data blocking, and data sensitivity. A hardware guard is a device that has multiple network interface cards, so it's known as a multi-home device because it connects to multiple networks, which is used to control the flow of data. Generally, that flow of data is going to be from a less trusted system to a more trusted system. So, for example, we may have email flowing from a less trusted system to a more trusted system. And the hardware guard will have a set of policies and rules to make those decisions as what is allowed to flow through. Discretionary access control, which we call DAC, enables the owner of the resource to specify which subjects can access the object and assign granular permission, for example, read and write. So again, here it's going to be the owner that has the discretion to assign these permissions. Access is based entirely upon the identity of the user, so we don't have clearance here, we don't have security labels, or the group that the user is a member of. The owner can also choose to delegate the right to assign discretionary access control to other subjects. Discretionary access control is enforced through either access control lists or capabilities table. So the key here with discretionary access control is it is the owner of the resources can specify which subject can access the object and can assign the granular permissions. So let's just look at a simple DAC matrix. You can see here that Bob is the owner. We have file A, file B, and file C. Bob is the owner. Perhaps he gives himself full control, or he has inherently, because he's the owner, full control of file A, B, and C. And he chooses to assign to Alice on file A that she can read and write file A, she can read only on file B, and she has no access on file C. But Bob is the owner, so Bob gets to make these decisions. Role-based access control assigns access and granular permissions based on an operational role. So role-based is often referred to as non-discretionary because neither the subject nor the object owner has control over role assignments. RBAC allows a many-to-many relationship, so a subject can be assigned to more than one role, and multiple roles can be granted access and permissions to an object. So again, we're basing this on an organizational role, not on an individual entity, not on a group, not on a security label, but on a very specific role. So let's look at a simple RBAC matrix. So we may have file A and it's got ship's orders, file B is the ship's journal, and file C is the menu. We say the captain, regardless of who the captain is, can have full control to the ship's orders, can have read-write to the ship's journal, but can only read the menu. The first mate, regardless of who the first mate is, has no access to file A, can read the ship's journal, and can read the menu. And the cook, regardless of who the cook is, and regardless of who the owner of the files are, can have no access to the ship's orders, file A, no access to the ship's journal, file B, but can read and write the menu. So again, here we are looking at roles, so the types of permissions they have is totally based on the role, and then we will assign subjects to roles. Role-based access control can also be used to enforce separation of duties. We can have what's called SSD, which is static separation of duties, which constrains certain combinations of role assignments. So perhaps you can't be both the captain and the cook. Static separation of duties says that we cannot assign a subject to certain combinations of roles. Dynamic separation of duties, referred to as DSD, constrains certain combinations of role assignments that can be activated in any one session. Now it's dynamic because it really can change from session to session. You're in one role, or a subject is in one role, and whether they can activate or take advantage of the permissions they have from another role totally depends on what their activity and actions are. There are 4 different role-based architectures. We have non-RBAC, limited RBAC, hybrid RBAC, and a full RBAC. In a non-RBAC environment, well, it's just really not RBAC. There's no roles are used. In a limited RBAC environment, subjects are mapped to roles, and subjects are mapped directly to applications that do not support roles. So you may have this environment where some of your applications do support roles, some don't, And so we are going to map a subject to their roles, but we will also just use individual or group permissions when an application doesn't support a role. In a hybrid RBAC, users are mapped to multi-application roles and selected rights assigned to those roles. But there may be multiple roles that you have to assign a particular user to or a particular subject to. In a full RBAC model, the user is just mapped to an enterprise role, and those same roles are supported across all of your applications. So non-RBAC, limited RBAC, hybrid RBAC, and full RBAC. So let's review what we just talked about. We said we had DAC. Data owners decide which subjects are given access. The access control list or capabilities tables, both of which we'll be looking at in later lessons, are used to enforce the security policy. We have MAC, mandatory access control, where access is based on the relationship between the subject's clearance and need to know and the object's classification. And we use security labels to enforce the security policy. And then RBAC, access is based on the subject's assigned roles, and roles are used to enforce the security policy. So that brings us to our lesson 5.6 review. In this lesson, we talked about our various access control models and techniques. Mandatory access control, or MAC, which is where we're going to have security labels applied to both subjects and objects, and the subject security label has to be equal to or greater than the object's label. We have discretionary access control, which is assigned by the owner, and we have role-based access control, which is where we assign a subject to a role and the permissions are assigned to the role. So that brings us right to our 5.6 match the meaning. The terms I really want you to be familiar with and comfortable with are MAC, DAC, RBAC, classification, clearance, an object guard, RBAC SSD, and RBAC DSD. So go ahead, take a few minutes, put me on pause, match up the meanings, then come on back and we'll go through them together. All right, let's go through our lesson 5.6 terms. MAC means we have access by classification and clearance. MAC is mandatory access control. DAC is discretionary access control, and access is assigned by the owner. RBAC, role-based access control, is where access is assigned to roles. Classification is a label that we give to objects. Clearance is a label that we give to subjects. Remember, subjects have to go through a vetting process, a very extensive background check, and then they will be assigned a clearance level. An object guard is hardware or software that's designed to enforce a secure exchange of data in a MAC model. RBAC SSD is using role-based access control to enforce static separation of duties. And RBAC DSD is when we used role-based access control to enforce dynamic separation of duties. That brings us to our end of lesson, CISSP exam tips. Your 3 tips for this lesson are 1, that the operating system, and I would add here the application, must support the access control model. So the operating system or the application will dictate the model. The second is that role-based access controls, RBAC, can be used to enforce separation of duties, and we looked at static separation of duties and dynamic separation of duties. And then in a DAC environment, you want to remember that the owner can delegate control decisions. So while the owner has the authority to assign permissions, they can also delegate that authority to other users. So thanks for joining me for this lesson, and I look forward to seeing you in the next.